Feedback Circuit Analysis Part 1. We will be using a non-inverting amplifier to illustrate the feedback circuit analysis process. First, we need to identify the topology of a non-inverting amplifier. As we know, a non-inverting amplifier is a series mixing, shunt sampling topology. Next, we will separate the feedback network from the basic amplifier, followed by finding the following three parameters. 1. Input resistance of feedback network, R beta input. 2. Output resistance of feedback network, R beta output. 3. Feedback factor of feedback network, beta. First, let's find the feedback factor, beta. From the feedback circuit, we can see that beta equals to Vf over Vout. Therefore, beta equals to R1 over R1 plus R2. Before we proceed to analyze the input or output resistance of feedback network, R beta input or R beta output, we need to apply certain conditions. The conditions are: 1. For series mixing or series sampling at the feedback network input or output, sever the connection of feedback network input or output. 2. For shunt mixing or shunt sampling at the feedback network input or output, short the connection of feedback network input or output. With these conditions known, we can now proceed to find the input resistance of feedback network, R beta input. From the feedback circuit, we can see that at the feedback circuit output, which is also the basic amplifier's input, represents a series mixing. According to the conditions stated earlier, we need to sever the feedback circuit's output. Therefore, we can see that the R beta input is equals to R1 plus R2. Next, we shall proceed to find the output resistance of feedback network, R beta output. From the feedback circuit, we can see that at the feedback circuit input, which is also the basic amplifier's output, represents a shunt sampling. According to the conditions stated earlier, we need to short the feedback circuit's input. Therefore, we can see that the R beta output is equals to R1 parallel with R2. Up till now, we have managed to find the values of R beta input and output. With the values of R beta input and output known, we can redraw the new amplifier circuit, A', without the feedback network, but with R beta input and output obtained earlier. Next, we can replace each active device in the new amplifier circuit, A', by a proper model, H parameter or hybrid P model for example. With a new amplifier circuit represented by proper model, we can proceed to evaluate the amplifier gain, A' of the A' circuit, the input and output resistance of the A' circuit, with R beta input and output included.